So this is part 284C3K5. It's a whole series of videos in line K that you want to look at about hydrogen storage, okay? They all go together. Line 22f1fa19c3k5, hydrogen storage metal decorated carbon nanotubes 5G Wow Seti. There's the alien radio signal that brought up the data. August 4th is when I started working on this data, and today is the 27th of August 2012. So metal decorated single wall carbon nanotubes for hydrogen storage at ambient conditions. So this is a quote from PDF files that came up with these as keywords, okay? It's from the University of Twente, Netherlands. Okay, objective. The primary objectives of the proposed project are to explore innovative idea of application of metal decorated carbon single walled nanotubes SWNTs for vehicle onboard hydrogen storage with a capacity reaching of or exceeding 5 WT%. I know your goal is 6%, right? At ambient conditions, to develop scientific basis of the rational design of metal decorated carbon SWNTs on microfiber support, and to arrive at a fundamental understanding of their structure, hydrogen absorption, performance relationships. The technical goal of the project is to demonstrate under realistic semi-technical conditions applicability of the developed sorbents for vehicle onboard hydrogen storage at ambient conditions to follow directives 2003/30 EC. The economic and social goals of the proposed project are in providing new technological knowledge on the preparation and performance of a new class of reversible hydrogen storage absorbents. So you want it to be reversible. I'm just taking notes here. Which will ensure a step forward in development of novel transportation technologies based on the application of environmentally friendly hydrogen fuel. Oh, so you want hydrogen fuel. Okay. I didn't know what you wanted it for, now I do. The originality of the proposed research and technological methodologies, whatever, will be an application of atomic layer deposition for decoration of carbon SWNTs with metal species and the development of the hydrogen sorbent in the form of quartz and high temperature silica glass microfibers. Ah, you guys need glass microfibers, and that glass came up. There we go. Ha! You need microfibers. Okay, hold on. We had the microfibers came up. What were they called? They started with a B. Which will facilitate fast hydrogen absorption, desorption performance with multi-cycle operation. On project successful completion, and the main deliverables will be novel nanolayer catalysts of 20 to 200 nm thickness on microfiber quartz, high temperature silica glass supports for the synthesis of carbon SWNTs of 1 to 2 nm diameter and microlength. Carbon SWNTs decorated with metal TISCV, FE, NI, CO, PT, and PD species by atomic layer deposition of organometallic precursors, including transition metals. Oh wow. And okay. They're saying, I'm saying oh wow because there was just a line of transition metal comes up. And it was a real boring section. It was all those super alloys that we did in the videos. There was like 26 of them. Huh. I thought they had something to do with the actual outer shell, but I'm beginning to think it's part of the fuel, but I didn't know that. Sorry. Fundamental relationships between the dispersion or localization of metal species on carbon SWNTs and their H2 absorption performance. H2 absorption. So I'm gonna make a new formula then. Okay. I'll put that in another video, so you know, I'll just go through the videos and do that. Okay, novel microfiber sorbents based on carbon SWT is decorated with the metal species for hydrogen storage at ambient conditions with H2 storage capacity reaching or exceeding 5 Wt% and fast hydrogen absorption, desorption performance in multi-cycle operation. Recommendations and most promising directions of further increasing of hydrogen absorption capacity of the developed microfiber sorbents based on carbon SWNTs decorated with metal species. It's like it's repeating itself. The proposed project addresses the needs of the European producers of fuel cell vehicles. The production of developed hydrogen absorption materials will need minimum scaling up. Their commercialization strategy can be realized on a licensing scheme. The project consortium is composed of 5 partners from 4 countries: Russia, Spain, the Netherlands, and Ukraine, and integrates the experts in nanomaterials science, catalysts, surface chemistry, and sorption technology. Achievements started 2006 till 2008. So I guess this is the project that they did and what they did. So cordis.europa.eu is where you'll find the research there, okay? So the next PDF quote is going to be from Hydrogen Storage and MgH2 coated single-walled carbon nanotubes. And there's our scientists that worked on it. They are from Dayajara, India. Boy, you guys are really all over the place now. Sorry. We're going all over the world here, aren't we? Literally. dx.doi.org is where their file is. Abstract quote, we present a density functional theory, DFT, study on the hydrogen storage capacity of 5 armchair single-walled carbon nanotubes, SWCNTs, functionalized with magnesium hydride. Magnesium hydride is the key word. I'm going to write that down. Magnesium hydride, or MgH2. Okay. Being lightweight and rich in hydrogen, and contains hydrogen. It absorbs H2 molecules in the vicinity of carbon nanotubes. The H2 molecules are absorbed dissociatively on SWCNT plus the MgH2 complex. The HH distance gets increased by more than 10 times of the initial bond length of the H2 molecule. And you have an increase in your bond length. Okay. The hydrogen storage capacity of 3 configurations, namely C1 MgH2, C5 MgH2, and C10 MgH2 is reported. So that's what they were able to create. The density of states is computed for all the systems. The average binding energies, again, the key word is binding energies, right? This is very interesting. Every time I got binding energies, I thought I was talking about nuclear fusion. I'm sorry, I don't know what I'm doing. The density of states is computed for all the systems. The average binding energies is C5 MgH2 and C10 MgH2. One H2 molecule absorbed are 1.86 EVH2 and 1.96 EVH2, which are approximately equal. Thus increasing the number of MgH2 molecule does not vary the binding energy H2 absorption. The corresponding temperature in which desorption will take place is 2285 K. That's a lot higher than the other guys. They were 600, right? And 2457 K for C5 Mg2 and C10 Mgh2 systems, respectively, which are much above the room temperature. www.sciencedirect.com. Again, in the other videos, some of the signal data and graphs that came up is in relation to the Higgs Boson signal. So keep that in mind when you're doing this. Look at the Higgs Boson notes under ATLAS, the YY photon, and obviously it has something to do with the standard model, and all this all has something to do with each other. Okay, we're going to go to the next video now.